Kristen, yes, you can do that because you're done all the tasks. So yes, you can go and leave the meeting and do that. That's fine. Good luck. Okay, so let's have a look at the first one. The first one's pretty straightforward. We are going to kind of follow our strategies. I'm just going to write this on a different page. What is it? Sin x, tan x. On the left side, and then on the right side, we have secant x minus cosine x. Okay, so on the left side, I'm going to follow my strategies of changing everything to sine and cosine, and then see what happens. So I know that tan x is equal to sine x over cos x. So this is the left side. And then what I would like to do is simplify, right? We always change to sine and cosine and then see what we can do to simplify. So the only thing I can do here is just multiply these two terms together. So sine x times sine x is sine squared, and that's over cosine. So that's all I can do to simplify. So then I'm going to go over to the right side and do the same thing. So secant is 1 over cosine. So I will do that. This is the right side. And then I ask, well, what can I do to simplify this? Well, I could find a common denominator. So my common denominator is cos x. I think I did this one the other day. So I would need a common denominator of cosine. And cosine times cosine is cosine squared. And then once I've simplified both sides, I sort of compare. And I say, okay, well, the denominator is the same, but the numerators are different. But I know 1 minus cosine squared is equal to sine squared. Okay, I think I did that one the other day. No one else is waiting to get in? Okay, I think I did number 2 as well. So I think I already did number 2 the other day in the lesson. So let's go to number 3. So we have secant squared x minus secant squared y. And that's on the left side. And then on the right side, we have tan squared x minus tan squared y. Okay, so same strategy applies. I am going to change terms to sine and cosine and then see what I can do to simplify. So secant is equal to 1 over cosine, so that would be squared. And likewise with secant squared y, oops, that would be equal to 1 over cosine squared y. What can I do to simplify? Well, I have a fraction minus a fraction, so I can find a common denominator and put them together as one term. So the common denominator would be cos squared x, cos squared y. So this one would have to get multiplied by cos squared y, and this one by cosine squared x. So in the numerator, I get cos squared y minus cos squared x. And that's all I can do to simplify. Okay, so I'm going to go over to the right. You can continue to work down one side if you want. Well, let's say we were going to continue working down this side. You could separate these terms now that you found a common denominator. So you could say cos squared y over cos squared x, cos squared y minus cos squared x over cos squared x, cos squared y. And then you could reduce, right? Well, no, then we're going back to the beginning. Let's go down the other side. I've just got to let somebody in the lobby. We're going to go in circles if we go that way. Okay, just let me, who's coming in? Oh, Ivan is leaving. Okay, so I've simplified the left, I've changed the sine and cosine, I've simplified it, so let's go down to the right. So I'm going to change tan to sine over cosine, and sine squared y over cos squared y. And then if I wanted to add those two terms together or subtract, I would need to find a common denominator of cos squared x cos squared y times, must be Friday. Okay, common denominator is cos squared x cos squared y. So this one needs to get multiplied by cos squared y, and this one needs to get multiplied by cos squared x. So that leaves us with sine squared x cos squared y minus sine squared y cos squared x. So when I compare, I will notice that the denominators are the same. So that's good. The denominators are the same, but the numerators, why does Ivan keep leaving? If anybody's talking to him, tell him to wait in the lobby. He's trying to get in. So sine squared, lost my train of thought there. So the denominators are the same, the numerators are different. So when I look at the numerators, on the right side, I see that it has sine and cosine, but on the left side, I see it only has cosine. Hi, Ivan. You're a little bit late. You have to wait in the lobby. Okay. Okay, so on the left side in the numerator, we only have cosine. On the right side, we have sine and cosine. So what I want to do, and this is where it's replacing something for a reason. Okay, so I talked about that previously. Don't just change things for no reason at all. If you're going to change something or replace something, you need to do it for a reason or a purpose. So I don't want this, and I don't want this, right? Those are the two terms in the numerator I don't want, and those are what I'm going to replace. So I know, I'll give myself a bit more room here. So I know that sine squared equals 1 minus cos squared, and that's x. So I'm going to replace that. I want to replace it with something with cosine instead of sine. And the same with the sine squared y. I'm going to replace that with 1 minus cos squared y. And then we can expand. So we're going to multiply cos squared y times 1. Cos squared y times cos squared x. Then we're going to have minus 1 times cos squared x. And then a negative and a negative is a positive, and I get cos squared x, cos squared y. Running out of room there, all over cos squared x, cos squared y. And then I see that minus cos squared x, cos squared y, and plus cos squared x, cos squared y add to 0, which leaves me with cos squared y minus cos squared x. And now we have left side equals right side. Okay, so the strategy being change everything to sine and cosine. What can you do to simplify it? So on the left, we found a common denominator, and then we just left it. We went over to the right, we did the same thing. We changed to sine and cosine. What can we do to simplify? We can add those terms together by finding a common denominator, and then we compare. So when I compare, I see the denominators are the same, but the numerators are different. How are they different? Well, the one on the right has sine in it, and the one on the left does not. So I want to get rid of that sine by changing it to something with cosine in it. And then once I do that, it kind of all falls into place. Okay, let's go to number 4. So we did number 3. Okay, I'm going to show you 2 ways to do number 4, kind of a long way and a short way. Because remember that there's more than one way to do these sometimes, depending on how your brain works and how you see things. So cos, actually I have this written out, so I don't have to keep going back and forth. Okay, so let's go do number 4. Okay, I'm going to do it the long way first. So on the right, it's just cosine. So I don't have to do anything on the right. I'm just going to work down the left side. So I'm going to expand my compound angle formula. So this is the compound angle formula, and I'm going to look up my identity sheet, and I'm going to write out the compound angle formula for cos x plus y. So that would be cos x cos y minus sine x sine y. And then all of that is multiplied by cosine y. And then I'm going to do the same thing here. I'm going to take the compound angle formula for sine x plus y. So I'm going to write that out, which is sine x cos y plus cos x sine y. Running out of room here, and that's all multiplied by sine y. Okay, so then I'm going to expand my bracket. So I'm going to multiply cosine by cos x cos y. So cosine x cosine squared y, and then the next term would be sine x sine y cosine y. And then the next bracket is sine y times sine x cos y. And then finally cos x sine squared y. And then I notice that these two terms add to 0, which leaves me with cos x cos y, cos squared y, plus cos x sine squared y. Okay, well that doesn't look like the right. So what else can I do? Well, I notice that there's a common cosine. There's a common cosine, so I'm going to factor that out, which leaves me with cos y squared plus sine squared y. And what do I know about this? I know that that is a trig identity that equals 1. So I'm going to show that. I know that equals 1. So cos x times 1 is cosine x. Okay, so that's kind of the long way. Expand your compound formula, multiply out your brackets, see what you have, collect like terms, and then kind of compare. So I see a common cosine, so I'll separate that out, and then what's left in the bracket equals 1. Okay, so that's kind of a long way to do it. And I'm just going to show you shorter ways. Some people get this, some people don't. But we'll have a look at it because this is a valid option. Okay, so if you look at this, you've got cos x plus y, cos y, plus sine x plus y, sine y. If you think about your compound angle formulas, so if you look at your identity list, you might say, well, that kind of looks like the compound angle formula, cos x cos y plus sine x sine y. Right? The only difference in that is that instead of x, we have this bracket. Right? Other than that, it's the same. So it's cos x cos y plus sine x sine y, but instead of x, there's a bracket x plus y, but it's the same in both. So cos x cos y plus sine x sine y is the expanded form of cos x minus y. Right? These are equal. So if I expand cos x minus y, I will get cos x cos y plus sine x sine y. So the identity is given in the expanded form, and I'm going to contract it back to the cosine x minus y form. But instead of x, it's that bracket x plus y. Okay, so I'm going to expand it or contract it back to cos x minus y. But instead of x, it's x plus y. And when I collect like terms, I get cosine x. Okay, so that's just a different way to do it. Sometimes the identity is given in the expanded form of the compound angle, and you can contract it back to the original form. But you just have to be careful that sometimes the x and the y are something different. Okay, and there's one coming up later that we'll look at. So if you understand that, it is perfectly legitimate to do it that way. You just need to include this step right here. Okay? So I need to know that that is what you are doing, that you're using the compound angle formula. So you need to go from here to here, okay, to show me that you know what that is the compound angle formula. Don't go from here directly to cosine x, because then I don't really know if you know that it's a compound angle formula, if that makes sense. Okay? So remember I said that you need to try and make it clear that the steps that you're doing. So to show me that you are using the compound angle formula, include this step cosine and then x plus y minus y, so I know that's what you're doing. Okay? Or you can do it the long way, which is fine too, right? So the long way is expand it, collect like terms, and then go from there. Okay? And we'll look at one similar to that. I think we have one later that's tan. Or actually, the next one is. So the next one, number 5, is similar. We're going to use the compound angle formula. So on the left, we have this. Okay, so I could expand this, and it would be a really long question. Or we're going to use the compound angle formula. And this one looks similar to tan x plus y. Right? If you look at the formula for tan x plus y, it's tan x plus tan y over 1 minus tan x tan y. And that looks a lot like this question, right? I'm just going to keep this separate. So this identity looks a lot like tan x plus y in expanded form. So I'm going to go back to tan x plus y, but you'll notice that it's not x, it's x minus y, right? So the only difference in the expanded form is instead of tan x, it's tan x minus y. So when I go back, all right, so my next step would be tan x plus y, but instead of x, it's an x minus y. So I'm showing that step that I'm using the compound angle formula. And then if I just collect like terms, x minus y plus y is x. So that's a quick way to do that one. You could do it the long way. You could change tan to sine of a cosine and all that, but that would be a pretty long question. So that's just a hint on doing that a quick way. And you can always go back and look at these, right, if you don't get it the first time. Okay, this one has something tricky in it as well. Okay, so I'm going to leave the cosine negative x for now. Just let's leave it. So cosine pi minus x is a compound angle, right? So I'm going to use the formula cosine x minus y. So I'm going to expand this into cos x cos y plus sine x sine y. All right, so it'll be cosine x, well x is pi, and then cosine y, which is x, and then plus sine x, x is pi, and sine y, y is x. Okay, then I'm going to go through and see if I can put in some values. So cosine of pi, well, if you think of your cosine curve, right, what is the value of cosine at pi? It equals -1. Okay, so I can replace cosine of pi with -1. And then sine of pi, well, let's look at the sine curve. What does sine equal at pi? It equals 0. So I can replace sine of pi with 0. So that eliminates this term because 0 times sine x is 0. So now I have cosine -x minus cosine x. Well, what does cosine of -x equal? So cosine of -x is the cosine curve reflected horizontally, because the negative is on the x. So it's reflected horizontally over the y-axis. So the reflection of this curve is that, and then that would look like that. So that would be cosine -x, right? Reflected over the y-axis. Well, it's the same thing. Cosine -x is the exact same as cosine x. So I can replace cosine x, cosine -x, with cosine x, because it's the same thing. Okay, so that's the little tricky part. So cosine -x is actually the same as cosine x because it is the horizontal reflection over the y-axis, and so it's the same graph. Okay, then I'm going to expand the right side. So this is a compound angle cosine x plus y. So we're going to expand that into cosine x, cosine y minus sine x, sine y. So cosine x, where x is pi, cosine y, where y is x. That's not confusing. And then sine x, x is pi, and sine y, y is x. And then we have a plus cosine x. So cosine of pi, we already agreed was -1. And sine of pi is 0. So then we have minus cos x, that's 0. And then plus cos x is 0. So we get left side equals right side. So that one's a little tricky, right? We have some compound angles, and we have to know that cosine -x is the same thing as cosine x, and we also need to find values like cosine pi and sine pi. All right, number 7 on that page. So I'm just going to do that one page, and then next week we'll do the other page. The other page has, I think, 18 questions on it, so we'll split that over 2 days. So we'll just do the first page today, and then we'll do the other page over 2 lessons next week. And then you have all the answers to the identities that are in the guide, right? If you want any more identities, you can get some from the textbook, because there are some in the textbook. And I'll double check. I think the textbook is in the hub, but I'll double check that. Okay, so on the right side, I'm going to change secant to 1 over cosine, and I'm going to change cosecant to 1 over sine. And then what can we do to simplify? Well, we can multiply. Right, so that's all we have to do there. What can we do on the left side? Well, cosecant is the reciprocal of sine. So it's 1 over sine 2x. Don't put the 2 on the bottom, and I'm talking about this 2. This 2 is staying where it is, okay? It's 2 over 1. So it's not coming on the bottom with the sine 2x. It stays exactly where it is, because it's not a half, it's 2. Okay, so then I'm going to change sine 2x to 2 sine x cos x. And then I can reduce the 2's. And we get sine x over cos x, so left side equals right side. So that one's pretty easy. Okay, we're just changing to sine and cosine and simplifying, and we get the left side equals the right side. Okay, number 8 is similar. What time is it? Oh my God, 10 minutes. Okay, so on the left, we have 2 times cotangent 2x. And on the right, so on the right, it's already in sine and cosine, but it could simplify it by finding a common denominator. So my common denominator would be sine x cos x. And so this one would get multiplied by cosine, and this one by sine. So that leaves me with cos squared in the numerator, cosine times cosine, minus sine times sine is sine squared. Okay, and I'm just going to leave it for now because I can't really do anything else until I know what's going on the other side. So I don't want to just randomly start doing things. Okay, so over here, cotangent is equal to cosine over sine. So that's what I would replace it with. I would not replace it with 1 over tan. You could, but then you got to change tan. So rather than do it in 3 steps, I'm just going to do it in 1 step by recognizing that cotangent is the same as cosine over sine. Okay. So if you did 1 over tan 2x, then you've got to change tan 2x to sine over cosine, and then you've got to take the numerator and multiply by the reciprocal of the denominator, and then you'll end up with what I just got. Okay, so remember that cotangent, the other form is cosine over sine. So then I'm going to change the bottom. I'm going to wait and see what to do with the top because cosine 2x can come in more than one form. Right? So 2 sine x cos x is equal to sine 2x. That reduces. So then I look at the other side. Well, the other side, the numerator is cos squared x minus sine squared x. So when I'm picking my form for cos 2x, because there are 3 versions, I want to pick the version that's going to help me. And the version that I'm going to use is cos squared x minus sine squared x, because that's one of the 3 that I could use, which is the one that's on the right. Okay, so that's why I kind of want to wait and see what I'm going to do till I see what the left side's going to look like. And then left side equals right side. Okay, so you want to use whatever version is going to help you prove that identity. Okay, the last one is a hard one. So on the left side, there's not really much to do. It's in terms of sine and cosine. It's already simplified, so I'm just going to leave it. Not really anything to do there. Tan 2x. Okay, so secant is the reciprocal of cosine, so we'll change that. And then tan is equal to sine over cosine, so we'll change that. And these are double angles. Okay, so I'll change those to sine and cosine. I already see that there's a common denominator, so we'll bring both terms together. And then I'll change sine 2x to 2 sine x cos x. Okay, so now I have to decide what to do. So I'm going to compare. The left side has a denominator of cos x plus sine x. And the right side is cos 2x. So when I change cos 2x, the version that makes the most sense is the version that has cosine and sine in it, because the left side in the denominator has cosine and sine in it. So when I'm picking a version, I'm going to use the one that has both cosine and sine, right? Because my options are replace it with cos squared minus sine squared, or replace it with 2 cos squared minus 1, or replace it with 1 minus 2 sine squared. right? So the other two versions only have cosine or sine. This one has both. So that makes most sense to me to do that. And I know I can factor this because I'm trying to get cosine x plus sine x in the denominator. So I know this is a difference of squares. So I'm going to factor it. So that means I want to get rid of the cos x minus sine x, because if I look at the denominator on the other side, it doesn't have that. It only has this one, right? So I want to get rid of this one. So what can I do in the numerator? Well, if I am really good at factoring, I know that 2 sine x cos x is the middle of a perfect square. So I'm going to change 1. I know 1 equals sine squared x plus cos squared x. So I'm going to change the 1 to sine squared x plus cos squared x. I'm actually going to put the cos squared x at the beginning and the sine squared x at the end. So there's my 1, right? Cos squared plus sine squared equals 1. And the reason I'm putting cos squared at the beginning is because in the denominator, cosine is at the beginning. So that's why I'm going to put it that way. And then if I factor this trinomial, it's actually a perfect square. So it's cos x minus sine x twice. There's actually, if you did the 3U and you finished the course and you did identities, there's a very similar question in 3U. And then once I've factored it, I can reduce. Right, so that one you might have to do a couple of times to understand it. And you also have to do a bit of thinking about factoring. Right, so you have to be pretty good at factoring to kind of follow that logic. Okay, so when I'm doing it, I follow the same strategy. I'm changing everything to sine and cosine, and then I simplify it. Okay, then I compare the other side to figure out what am I going to do next. So my strategy was, well, cos 2x in the denominator, I have 3 options. I'm going to pick the cos squared minus sine squared because it has both cosine and sine in it. And then I'm going to factor it because I know one of the factors is the same as the denominator on the other side. Okay, so I'll factor it, which gets me to here. And then I have to figure out how to get rid of that one factor that I don't want. So that means I have to factor the numerator. And then I have to look at my options for that. Okay, so that one's kind of a tricky one. So you might want to go back and look at that a couple of times. So that was quite a bit. We're almost done class. I know that was quite a lot, but you can always go back and look at it. I did record it, so you can go back and look at them over again.